talk about some of the coil details, some of the mysteries of these coils, especially the opposed firing coils, the simultaneously firing coils that really are what was used in the 1920s.
So is that what we've got here?
Yeah. So
This would be a primary, and these would be
Yeah.
the two secondaries,
right.
all on the same piece?
So basically, the great Johnson quick action coil, even though it looks like there's one coil in here, there's actually two
It's
separate
this right here.
winding. Yes.
Primary, two secondaries.
Right. So there's one primary, which is a coarser. I'm probably not going to go into much magneto theory here, but there's.
I think that was well covered in those two
It was
articles.
very well covered.
As far as the coils
really
go,
well covered. So
very
there's
well
the
covered.
primary winding, which is quite a coarse winding, and then secondary windings. And the Johnson used actually once I took one apart. You can't quite
Very,
see it
very
fine in
fine
film,
wire,
but you can
yes,
see how
right.
fine.
Right.
You can see how fine that wire is. So the Johnson used.
Yeah, you can see it now. Yeah, all right.
Yeah.
Good.
Inside this phenolic tube, there's actually two separate windings. In fact, you can even see like a lot number. Somebody actually, whoever did this job of making these coils,
Okay.
they actually hand wrote a number on this winding.
Okay.
And,
It's different from that winding right there.
well, I think they're the same.
Okay, all right.
They should be the same.
Yeah. But what do you say, two different windings?
Well, they're separate. I should say separate.
Okay, we've got two separate
Right, they're-
secondary windings
probably-
on one primary.
Right.
Right.
So then they're assembled like so. But the important piece of all this is that they're tied together, and you can't really see it here.
Well, there was a wire going from
Yeah,
here
so-
to this one to this.
So you see right here, there's one of the tie wires.
Okay.
This one's I probably destroyed it trying
Right.
to take it apart. But when these are assembled, both secondaries
electrically
are
connected.
electrically connected.
And then there's separate two high tension coil wires going off to fire the two different spark plugs that
Right.
come off the
Yeah,
top.
Yeah,
Yes,
like
right there.
here. So
Right, okay, right there. Right, got it.
yeah.
So this would be two coils inside of here.
Yes.
Tied together.
Yes.
From this end to this end, and then the two separate other ends from
Right.
each one of them going to the spark plug.
And that's why
Okay.
when you check this with a meter, there's continuity between the two secondaries.
Okay, good.
And that's
excellent.
Yeah, and that's what makes these things work so well. That they both fire at exactly the same time because of that.
And this would be an example of some
So,
different type
yeah,
of
so
a
this
different
is-
company, but still the same secondary windings.
Right. So this is an Iseman,
Okay.
same idea.
Yep.
Two separate. These are quite big, actually.
And you do believe that these were wound. This was wound like this, and
Yeah.
then these two were wound separately
On a machine.
phenolic tube,
On
and
a
then
machine.
slid over the top
Yes,
of this, and then
right.
potted.
Yes.
Okay.
Yeah, right.
All right.
And it's actually interesting because one could say, well, what do we do these days when we need a good coil? And it's to me it wouldn't be that hard to find somebody to wind these things.
Yeah, that would be really nice. That it's like it seems to me, Bill, that I gave you that book on how to wind coils,
Yeah, right.
And with the hopes that you are a machinist, which you are, and you do a lot of machine work, that you would build one of the rather simple winding machines and
Right.
do these coils.
Right, because once we have these, then we can do anything. Really, I know. So that'll be another assignment. This piece here was part of this whole. There were two of these with some kind of a insulated.
An isolator, okay,
Anyway, so that's Johnson coil exploded.
All right.
Iseman here.
Yeah. And what are these? What is
So
this?
these are Iseman.
Okay.
This is Lockwood Chief. This is Lockwood Ace. This is just the Lockwood Ace without
without the primary.
without the primary on it.
Okay.
And so one of the challenges that we have is what to do with a bad coil, and it's the Johnson is kind of the gold standard in the industry about what a good on good coils. So usually they're good. Iseman's, on the other hand, and American Bosch seem to be usually bad. Okay, so what does one do when you have a Lockwood, a nice Lockwood that has a bad coil?
Well, there used to be a guy named King who wound those coils.
Yeah.
I have one in my Lockwood Chief.
Right. Yeah.
It's a nice coil. He
Okay.
wound those in Massachusetts. He was a fellow who lived in Massachusetts
I know,
like you, Bill.
I know the.
And
yeah.
he also, yes, right, yeah.
Yeah.
They
So-
they weren't cheap. They were expensive, but they were
Right.
well worth the money.
Yeah.
Right.
Yeah. So, what would two of these cost is what it comes down to. You know, it's if you handed a guy a coil like this and say make it work, he's going to have to take it all apart. He's going to have to do what we did here. I mean, just
Right.
take the secondaries off, decide whether the primary is still good or not, and then rewind the secondary windings and put it all together for you. So I can see how it would be
Do you
expensive.
heat the Johnson coils to get them apart?
Yeah,
You
have
do.
to warm them up. Yeah.
How hot do you get them?
I don't have a number.
You don't?
No.
Do you heat them in the wife's toaster oven or in her oven?
No, I actually have a different method. I actually use a torch and I heat the ends. Okay.
Really?
I heat the ends pretty hot, and then I wait for the heat transfer to go through, and then I heat again a little bit, and then wait for the heat transfer to go through. And eventually the core is warm enough where you can slide it apart.
I bought myself a used rotisserie oven.
Yeah. Okay. Yeah.
So what's this jig right here?
All right. Well, no, that's not
Okay.
not yet.
You're not there.
Okay. So
Okay.
we're doing the repair, and one of the things I'd like to cover is the Iseman magnetos, because they tend to be the ones that are the weakest as far as over time. They just seem to go bad. And
Secondaries, primaries?
yeah, primaries.
sec-
I've never seen a bad primary.
Right.
Although I did run into one where I had a primary, I think it was an Evernude, where I assembled the whole mag and I didn't have spark at all. And when I checked, of course the secondaries are fine, everything. When I checked continuity for the primaries, I found out that they were grounded. In other words, from here,
The coils were touching the laminations.
the primary actually in one spot was touching the lamination,
Yeah.
so it was kind of short at the ground. And I was still able to fix it by just taking that and grounding that side and still using the other side to the points. And it worked very well, by the way. But so anyway, one of the techniques I developed is putting new secondaries on the Iseman primaries. And I found out, and just by luck, is that the Johnson, this happens to be from a Johnson PO. Again, warmed up, slid off its primary winding, and now you have this assembly, which is two
Two of
of the
those, yeah.
secondaries still on its phenolic tube, undamaged. And it turns out, by luck, that these are the same
Diameter.
the same diameter.
Wow. All right.
Almost. I mean, it's a little bit loose, and this one I'll shim with something to get it tight and
Something
centered.
paper. Something
Yeah,
non-conductive.
I've used black electrical tape.
Okay,
Actually, you know,
okay.
nice wind
Yep,
and
good. All
and,
right.
and these work very, very well. By the way, I've done a few of these so far, and I've tested them, and they work fantastic. And of course, you know, it would be the same for the Ace as well. So you can do
Right.
the same thing.
I noticed you took the corners off of these
No, they
Or they come that
made
like
they
that.
made that way.
Okay,
You can
all
see
right.
that because that's how
because they had to slide them together.
they had to
Okay,
do this
yeah,
exact same job.
All right,
And,
okay.
You know, so you know, this is a you know the Iseman secondaries. And
Yeah.
it's the same. You know, it's the same
Right.
same deal. So
Yeah. Gotcha.
you know, yeah.
All right.
So that kind of simplifies this. What's going on inside this?
So you've got one method here to repair an Iseman coil.
Right.
These
Yeah.
use the secondaries from a Johnson
Right.
coil, which are fairly popular and usually good.
Usually good.
So I see you have another
Yeah,
repair
so-
over here.
Right. So another technique actually I think Jim Moffat developed this technique, and it's given hope to a lot of these Iseman mags that for people that haven't been able to find a replacement coil other than going and buying 2 new OMC coils. The advantage to this repair is that it offers coils that you can buy readily
Right.
available from
Right.
Napa or anywhere
Okay.
else. One of the disadvantages is the fact that you've got to get these coils on the original iron laminations, which is here. So you're not going to slide those coils over this dog
Right.
bone at all. It's not going to happen. So the disadvantage, of course, is now you have to get these coils on, and people have actually cut these, and they've staggered the cuts, and it's kind of a big job actually to get it so you can spread these apart, slide the coils on, and then put them back together and have it all fit together is kind of a challenge. And it's
So how are the secondaries grounded on these?
well, they're grounded.
on these John Rood coils.
Yeah, they're grounded individually, and that's a slight disadvantage as well.
So your collapsing secondary, a collapsing secondary, may not be exactly at the same moment that
Right.
from
Might
one to
not
the
be.
other.
I mean, the whole magnetic flux thing is all happening just.
Where is the ground is tied to the primary ground at one side? Is that how they get their ground?
I believe
they tie
so,
them both.
yes.
in,
Right.
Both
Yeah. Yeah.
both of them are tied internally,
Yeah.
and one wire comes out of the coil.
Yeah, right.
So you cannot ground, you cannot connect the two
The secondaries,
electrically, the
right.
two
Yeah.
secondaries,
Right.
like
Right.
you're connected here and
Right.
here.
And
with
that's what makes these so great is the fact that they're tied together. And
So your belief is that the timing is slightly off with
possibly,
that fix.
Yeah.
Yeah.
Is it
okay.
off enough to notice? Well, I don't know. That's subject to opinion. And my opinion is I seem.
Bill, that all comes down to one thing. When you've got two similar engines racing on two similar boats,
Right.
who's the fastest?
Yeah, it's me.
Who
course,
gets?
it's me.
What do you mean you?
It's me. It's me. Right. Yeah. The other repair technique for the Ace magnetos, and actually the Ace size coil was also used on Neptunes and also the Cross Seagull, is using an Evernute Speedy 4 coil. The Evernute Speedy 4 coil is almost the same as found. It has the same almost asymmetrical
Okay.
laminations. It's the only difference is that the radius is slightly different.
Okay.
And the hole location is slightly different.
Okay.
So I came up with a fixture.
Well, I thought you were going to tell me that was a winding fixture you were working
No,
on.
not yet. I guess that's probably next. So this fixture is based on, I actually took the Iseman Magneto and drew it all on AutoCAD
Okay.
and developed this fixture based on all the important dimensions, like where these, are in relation of these into the center line and the full diameter of the flywheel, and so I made this fixture as a result of that. And all this fixture does is it's a guide for reshaping this correct diameter on these.
How do you do the reshaping?
I do it with a belt sander by eye.
Okay.
It's not that
All right.
far off.
Yeah.
And then I use this fixture to verify, to make sure I have a good
Yeah.
match. And once they're matched,
Well,
it goes in the fixture and the holes get moved.
so we have an air gap that people talk about the
Yeah,
air gap, and
it's about 10 thou.
Like the Bendix scintilla, the air gap is very critical.
Right.
And on the Phelon, this is talking 50s engines,
Yeah.
it's not. The air gap can be quite varied and still get a very good spark.
Right.
So basically, I would say that these ignition systems, being that they're quite old, and this was an area of very low tolerance or high tolerance differentials, that these magnetos work. You can shape
Yeah.
something by
All
hand.
you're
They
doing
come
is
close.
you're making a magnet
Yeah,
across.
right.
That's
yeah,
all you're doing.
right. Exactly.
I mean, it could be a mile away.
Right.
And it's still doing the magnet.
Right.
I mean, it's better to have it close.
Right.
Right. To get the higher strength of the magnet. But that's all you're doing, is just getting that magnetic flux through the.
While we're talking about magnetic flux,
Yeah.
have you Have you ever in your experience of working on these things since 1972 when you joined the club?
Yeah.
Have you ever had a flywheel that needed to be recharged?
Never.
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 My experience is likewise.
Right.
I have a magnet charger. It's never made one iota of difference in my spark. My problem was always elsewhere.
Right. Oh, for sure. I've have a bunch of flywheels here, and they probably have never been recharged for all we know, and they're magnet.
Well, we can take it up and try charging if you wish.
Yeah, we should try to see if we can,
right.
Get the spark to jump.
You have a
half
sparker tester you've got down there? Yes,
do.
maybe
But
we can do that.
We'll talk about that in a moment here.
Okay.
I just wanted to make sure that we're done with these Iseman repair techniques.
So
Now-
basically, somebody to use the Evinrude would have to send it to you to have it shaped.
Yeah, I mean, they could do it by eye probably, and they could just guess it where these holes are.
Okay.
But this actually, and I've done quite a few of these now, is that when these coils go in, they fit perfect. There's not too much fooling around with.
Good.
This is a number 12 screw and a 1/4 inch hole, so there's a little bit of play, but not much. But they go in very well. The problem with all these things are that where do we get Speedy 4 coils, right? I mean, not everybody.
Well, I'm a Mercury man, so wrecking an Evinrude's no problem at all.
Yeah, right. Right. So, well, there's a lot of already wrecked Evinrudes, and the only reason why I've been able to be successful with finding these Speedy 4 coils is I go to meets and I pick through people's junk that they're trying to sell stuff, and when I see like a Speedy 4 Magneto, I grab it, I buy it. But right now I'm down to really no extra. I might have one extra coil right now in my collection. So they're kind of hard to find, and it's it reverts back to we should be maybe doing these. We should be maybe winding our own coils.
You have the book. I gave you the book so you can make your own machine.
I might be able to do it in my sleep.
Yes.
Yeah.
Right.
So I'm going to also talk about a little bit of American Bosch.
Do you want me to keep rolling here?
Oh yeah, keep going.
Okay, all right.
We'll keep going. American Bosch coils are often no good.
Okay.
And the really cool thing about these are they're almost the same as the Johnson.
Okay.
This is an old American Bosch coil. This is a Johnson coil.
Yeah.
And you can see how the spline or tongue and groove kind of joint
Yes.
is almost the same. So
Same, yeah.
A Johnson coil actually will fit into the American Bosch heels. The hole may be off like a half a hole, but that's really easy to fix.
Yeah. Red
So-
tail file.
Yeah, you could do that. So again, it's a great fix. The Johnson coils work really good. Where do we get Johnson coils? Okay, I find them for the same way. I go to antique outboard meets. People have parts and pieces. I've recently somebody gave me a whole box of old coils, and some of them were no good, but some of them were good, and that's what I do. That's
There's
how
lots
I
of
keep
coils
these.
kicking around in hidey holes. I mean,
Yeah, there are,
our club has quite a few too.
Yeah. So the stuff is around. I would recommend to anybody find these coils. Find them, check the continuity, and use them. Whether you take them apart and use them, or if you have an American Bosch like a Hartford, Indian, or Kale, just do the.
Doing a continuity check gets you very close to saying that's a good coil. I mean,
Yeah,
I like the spark checker.
Yeah.
That's great. A Mercatronic or a Stevens, does do that extra step, but continuity tells you a hell of a lot.
Right. Okay. So this is a test fixture that I made for fixing Iseman Magnitos. And right now it's an Ace flywheel, Ace Mag, on the remains of a Lockwood Ace crankcase and remains of a Lockwood Ace tower housing that somebody had cut.
And you've got huge gaps on those plugs?
Yeah, we have big gaps, and
How many thousands would you
I
say they were?
didn't measure.
Okay.
It's easily 1/8 of an inch, if not
Okay,
more.
all right.
And
I'd say it was more.
It actually works quite well. It doesn't even need a full turn. It just needs to pop at the right time.
Yeah, you can see the spark.
Yeah.
Yeah, good. Both
Yeah.
sparking simultaneously. Okay.
So what we're going to do is this magneto is quite hot, by the way. It works really, really well, but we're still going to recharge the magnet in the flywheel with the hopes that it could even be made better. I don't know how
So,
it can be made better.
what are these little? Looks like you've got little, look like spark gap
So this is
things
a
that you
failed.
made.
This is what we learned yesterday, is that when I decided to make this tester, I said, well, we don't need to use spark plugs. We can just we could just do a test that to simulate the spark gap with wires, and the whole idea here is to try to simulate the spark plug. But one of the things we found out is that when these are set to the same exact gap as a spark plug, okay, and we're doing it visually now,
Yeah.
but
Close.
it's close. Actually, you could even go more. We don't get the same result.
But we're not firing two at once.
No, so-
what
right.
happens when you fire two at once with the same gap like you were doing with spark plugs?
Nothing happens.
You don't get any spark.
Nothing.
Right.
So to get it to work for both of them at the same time, the gap has to be reduced a lot. In fact,
Dramatically. Okay.
and even now, it's sparking, but not great. So, lesson learned is I had assumed that a gap is a gap. Okay, and Lincoln had showed me that no, the spark plugs actually can intensify the spark, and we checked some spark plugs with a meter. I always thought that the continuity between the center post electrode and here would be the same, and in fact, it's not. And I'm not sure why that is. Some plugs are resistor plugs, and some are not. Irregardless, I don't think that these are resistor plugs,
No, they're not.
but because they don't even say it, there's no R. I think usually
This
there's
one
R.
has resistance simply because it's in the milliamp meter. It was almost open,
Yeah.
so
Right,
it
so-
had very, very high resistance,
Yeah.
and it gives a very good spark.
Right. But at the same time, if you check the electrical continuity between here and here,
It was fine.
it was fine.
Right, but on a
So
milliamp
that's a mystery.
meter, it was
Yeah,
not.
no, it's not. Right. So
Right.
so there is a difference between using a spark plug to test and my test apparatus here.
So now you have two spark plugs to do the testing, so we're good.
Right.
Right.
It's drastically different, which is
Right.
just amazing that how close these have to be to get them to both spark. And